Lesson 7.2, Similarity and Transformations. Your objectives are to draw and describe similarity transformations in the coordinate plane and to use the properties of similarity transformation to determine whether polygons are similar and to prove circles similar. Your vocabulary word is similarity transformation. A transformation that produces a similar figure is a similarity transformation. A similarity transformation is a dilation or a composite, which means several dilations put together, and one or more congruence transformations, like translations or rotations. Two figures are similar if and only if there is a similarity transformation that maps one figure to the other figure. Translations, reflections, and rotations are congruence transformations. Let's look at an example. Apply the dilation D to the polygon with the given vertices, and then describe the dilation. So we have a mapping from xy to 3x, 3y, and we start with the points 1, 1, 3, 1, and 3, 2. In red, you can see the dilation as we've multiplied each number by 3. So 3 times 1, 3 times 1 gives us the point 3, 3. 3 times 3 is 9 and 3. And then 9 and 6. So this would be the transformation. If you note, you can draw a line through the 2 points straight through to the 0, 0. This is a dilation with center 0, 0 and a scale factor of 3. Let's look at another one. Apply the dilation D to the polygon with the given vertices and describe the dilation. So we have xy mapped onto 3/4 x and 3/4 y. So we multiply each of the points by 3/4, and we come up with negative 8, 4. Well, actually, no, the dilation goes to negative 6, 3, negative 3, 6, and 3, 3. Since both of the lines from the vertices go to the point 0, 0, we know this would be the center. Same with the points lined up the vertices at top. So we have a center of 0, 0 and a scale factor of 3/4. Let's look at a different example. We want to determine if the polygons with the given vertices are similar or not. So we have A at negative 6, negative 6, B at negative 6, 3, and C at 3, 3, D at 3, negative 3. And the figure HJKL, so that H is at negative 2, negative 2, J is at negative 2, 1, K is at 1, 1, and L is at 1, negative 2. ABCD maps to HJKL by a dilation so that XY equals 1/3 X and 1/3 Y. The way we can notice this is that negative 6, trying to map this to negative 2, negative 2, if we divide by 3, we get negative 2, negative 2. If we divide by 3 again for B, we would get 2, 1. And yes, we do get the negative 2, 1. Dividing 3 and 3 by 3 gives me 1 and 1. And dividing by 3 for point D gives me 1, negative 2. Since all of them have the same factor scale, this is a similar mapping. Let's look at another one. We have P at 2, 0, Q at 2, 4, R at 4, 4, and S at 4, 0. Then we have W at 5, 0, X at 5, 10, Y at 8, 10, and Z at 8, 0. This is not a similarity mapping or transformation because even though I could multiply times 2.5 for X and Y, and this would map the point P to point W, it does not match S to Z. If I find one vertex that I can't map using the same similarity ratio, it is automatically not similar. Let's look at these triangles. We have 3 triangles here. We have 1, 2, 2, 2, and 1, 4 for triangle ABC. And DEF is 4, negative 6, 6, negative 6, and 4, negative 2. This is a similarity mapping or transformation. If we map to ABC prime by a translation, we would have X plus 1 and Y minus 5. And then we can map this to DEF by a dilation, 2X and 2Y. Another one. FGH maps to F prime, G prime, H prime by a reflection. So we've reflected from the blue over to the red. So it's already on the correct side. And then we figure out how much larger these are. And we find that this is 3 times the size of this. So if we divide by 3, we will get these vertices. With circles, we have centers and radius sizes. So circle A with center 0, 0, and radius 1 is similar to circle B with center 0, 6, and radius 3. Let's look at the circle with C with center 0, negative 3, and radius 2. Circle A can be mapped to circle A prime by a translation, and then they are dilated with a scale factor of 3. For the second one, we can first of all map circle C to have the same center as D. And then we're going to have to blow it up or dilate it to be the same size as D. So we would say X plus 5 and Y plus 4 to move circle C to C prime. And then we find that the dilation factor is 2.5. And they are similar. Now you try. Apply dilation D to the polygon with the given vertices, describe the dilation, and determine whether the polygons with the given vertices are similar.